Okay, so this lesson we're talking about in chapter 3. The first few sections are all about inequalities, and the algebra that's involved in them is the exact same algebra that we did with regular old equations. So a few things is I want you to know what inequality symbols are. So one of them, you have the less than, the greater than or equal to, the less than or equal to, and the not equal to. Those are called inequality symbols. Okay, so what an inequality is basically a mathematical sentence that uses an inequality symbol, and really it has multiple solutions. Not infinite or no solution, but it has multiple solutions, and there's a graph for them. An equation is not to be confused with an inequality. All right, so pretty simple. So when we want to write inequality, it says what inequality represents the verbal expression all real numbers x less than or equal to negative 7. I like this x and this less than or equal to negative 7. So if I go x and I use the less than or equal to negative 7, it's really that simple. That is the less than. I like to think of this guy right here as an arrow, and the arrow points at the smaller guy. Okay, 6 less than a number k is greater than 3. 6 less than a number k is greater than 3. So I'm going to go k minus 6 is greater than 13. And we're going to learn how to solve that real quick, real easy here pretty soon. So you got it. Why don't you pause the video and go ahead and do the got it, and I'll see you back here in a minute. Now, for the next part, we're talking about solutions to inequalities. And a solution is what makes the inequality true. So usually there is a graph for it. And we're going to get eventually into the graphing part, but I just want to kind of just talk a little bit about how you do this. So how you do this is you solve the inequalities exactly like equations, and then you go from there. The only thing you have to worry about is if you multiply or divide by a negative. So if you look at this, 2x plus 1 is greater than negative 3. 2x plus 1 is greater than negative 3. I'm going to subtract 1. Now I got 2x is greater than negative 4. Then I divide by 2, and I divide by 2, and I say, okay, x is greater than negative 2. Now, is negative 3 bigger than negative 2? No, it is not. Is negative 1 bigger than negative 2? Yes, it is. But if you didn't understand that, you could have easily plugged negative 3 in. So you got 2 times negative 3 plus 1. Is that greater than 3? 2 times negative 3 is negative 6 plus 1 is greater than negative 3. So is negative 5 greater than negative 3? No, it is not. It is further away from 0, so it is less than, actually. Try negative 1. 2 times negative 1 plus 1, is that greater than negative 3? 2 times negative 3 is negative 2 plus 1, that is negative 1. And yes, negative 1 is greater than negative 3, so that is a solution. So I believe you have a got it beneath you right there. Why don't you go ahead and pause the video, and I'll see you here in a minute. Talking a little bit about graphs. So when you have an inequality, all right, I like to tell you this much. Okay, if it's less than or greater than, it's always going to be an open circle. It's always going to be an open circle. And if it's less than or greater than or equal to, these guys are going to be a closed circle. Okay? So n is less than 1. I'm going to put an open circle at 1, and I'm going to shade to the left, because as long as the variable is on the left-hand side, you can shade to that direction. A is greater than or equal to 0. Greater than or equal to 0, it's going to be a solid dot, and it says the arrow points to the right, so you go that way. F is greater than negative 3, so I'm going to open the circle here, and I'm going to shade to the right. Boom. And now this one's different because the variable is not on the left-hand side. So if I put x here and I put negative 2 here, the arrowhead is pointing at x, so make the arrowhead point at the x here. So then now you just put a solid dot there and you shade to the left. Okay, so be very mindful of this because this comes up quite often. Now, with that being said, let's dive in and take a look at a problem. So let's graph. What is a graph of 2 is greater than or equal to a? Well, the first thing I don't like is my variable is not on the left-hand side. So I'm going to put a here, I'm going to put 2 here, and the arrow is pointing at a, so I'm going to go like that. So then I'm going to go ahead and make my number line. I'm going to put a 2 right there. And now, is the 2, is it an open or solid circle? It is a solid circle because of that line underneath the inequality symbol. And do I shade to the left or to the right? I'm going to shade to the left because the arrow is pointing in that direction. So you have a got it. Why don't you pause the video and do the got it? For this problem, let's work backwards, and they give us a graph. They want us to use the graph to try to come up with a inequality. So what I'm looking at is, okay, -1. All right, I'm going to put -1 right here, and I'm going to put a variable. I'm going to go z for, I don't know, z for zebra. Now, is this going to be a solid or an open? All right, well, this is a solid circle, so it's going to be a equal to or greater than or less than or equal to. So put that right there. Now, the arrow is pointing to the right, so I'm going to move it to the right. So z is greater than or equal to -1. Now, this little symbol right here means it's open. So I'm going to put a 4 right here, and I'm going to put a y right here. And I know that it's open, and so it's pointing to the left. So I'm going to go arrow to the left. So y is less than 4. Oh, I'm sorry. You got it. Why don't you pause the video, go ahead and do the got it, and we'll come in with the last problem that we have to worry about. All right, this is problem number 5. And it says real world inequality. So write an inequality that describes a situation. Be sure to define a variable. So here, if you just look at the picture, it says trail rides starting at 1999, and B is 8 miles per hour. So when they say trail rides, I'm going to say T, and it starts at, so it's going to be greater than or equal to 1999 because that's the cheapest I'm going to pay. I'm going to pay more than that. Speed limit, that's the highest you can go, right? That's the highest you can go. So speed has to be less than or equal to 8. If I go a little bit below 8, I'm okay. If I go above 8, then I am breaking the law, and that is not cool. Okay, so that's where these come from. Now, if you look at the got it, in part B of problem number 5, can the speed be all real numbers less than or equal to 8? What does that mean? All real numbers means negatives. Can you have negatives? No, you can't. So technically, you could say that it's anything from 0 to 8 miles per hour. All right, I hope that made sense. I'm sorry this video went a little long. I'll see you in class, and may the force be with you.